Today we're going to look at the other half of lesson 10.6, which is about how we can do the opposite of what we did yesterday. So yesterday we were given a graph. Today we're either going to be given a picture of the graph or we're going to be given characteristics about it, and we want to put that back into an equation. So you have the same chart in your notes, and again, you don't need to memorize the information in that chart. You will have a version of that to use on the test. So feel free to reference back to that as we work through. So in this one, we are told we have a circle, so we want to find the circle equation. For a circle, there's only one equation, plus y minus k squared equals r squared. When we are done, the letters x and y should remain, but all the other letters should be turned into numbers that are going to come from our problem. So in the problem, we are told that we have a center at 9, 3. That's h and k. So we're going to take those and plug them into the h and k spots. So we get x minus 9 squared and y minus 3 squared. Then we're told we have a radius of 4. That radius is our r value. In the equation we want r squared, so we want 16. Questions? The circle is the easiest one. We're starting with the easiest one. So this one's another circle. So again, we've got x minus h squared plus y minus k squared equals r squared. For this problem, our centers are h and k. So when we take those and plug them in, we have to be a little bit careful on this because h is negative 2. So when we plug in that negative 2, we're going to have minus a negative 2, which is really going to give us a plus 2. And then y minus k is y minus 3. That's squared equals a radius of 7. 7 squared is 49. So you have to be a little bit careful when you plug in a negative h or k, because then you're going to end up with that double negative. All right, so a circle is a parabola. Now, you don't have to plot them, but for me, it's the easiest way to think about whether this is going to end up being horizontal or vertical if I can just plot it and see it. There are other ways to tell based on what the numbers are doing and looking at the problem, but for me, I just go ahead and do a rough sketch so I can see this thing and decide whether it's horizontal or vertical facing. Because for a parabola equation, that makes a difference. A circle equation is the same no matter what, because it can't be horizontal or vertical. It's the same every way. But a parabola, there's a different equation whether it's horizontal or vertical. So I'm going to plot my vertex at negative 2, 1. I'll put a V by that so remember that's my vertex. And a focus at negative 3, 1. Well, it should go through the vertex and around the focus, so that tells me that this thing is sideways. So then I want to look at my chart for my horizontal facing parabola equation. And the horizontal facing parabola equation is y minus k squared equals 4px minus h. A parabola doesn't have a center, so its vertex is its hk. So our vertex here is going to be our hk. So we can take those and plug them in. Being careful that we actually plug in the k where the k is. Don't just plug them in order, because here they're kind of backwards. So k is 1, and h is negative 2. Double negative is going to make a plus 2 in our equation then. Then we need to figure out about p. P is the distance from the vertex to the focus, and it's directional. So in our picture here, this length between the vertex and the focus is our p-value. So how far is the vertex away from the focus? 1 unit, and it's directional, so what way is this thing facing? A negative way, right? It's facing to the left. Left and down are negative facing directions. So to get from my vertex to my focus, I have to go negative 1 spot. I have to go backwards 1 spot. So our p-value is going to be -1. So I plug a -1 in for p, and that gives me then at the front of the equation a -4. Okay. So p is the distance from the vertex to the focus, and it's directional, so since we have to go to the left, this is going to be a negative p-value. Left and down are negative directions.
So how do you find the stuff that's with the y and the x?
That's our h and k, which is our vertex. H and k are the vertex for a parabola, center for everything else, but a parabola doesn't have a center, so then it's our vertex. Let's try another parabola. So again, you can kind of tell in some ways by thinking about where these points are, whether it's going to be horizontal or vertical without plotting it. But I think it's easiest just to plot it to see whether it's horizontal or vertical, and then that also makes it easy to find the p-value from your picture also. So our vertex is at 3, 2, and our focus is at 4, 2. Goes through the vertex around the focus. So this is horizontal facing again. So horizontal facing is y minus k squared equals 4px minus h. You don't have to memorize those, you can just read them right off of your chart. Our vertex for a parabola is our h and k. So we can take those and plug them in their spots. Y minus 2 and x minus 3. P is the distance from the vertex to the focus. So in the picture, from the vertex to the focus, we go a distance of 1, and it's facing right, which would mean that's a positive 1. So we get a 4. It could happen also in a problem that instead of being given information about where your focus is, you could have been told where the directrix is. So in this problem, instead of being told that your focus was at 4, 2, it would have been possible for them to say that your directrix is at x is equal to 2, which graphically x equals 2 looks like this. Your focus is always the same distance away as your directrix, just in the opposite direction. So if I didn't know where the focus was, but I knew where the directrix was, I could say, well, that's 1 away to the left, so the focus must be 1 away to the right. And P is always the focus value. So if you're given the directrix, you're trying to figure out how far away is that on the one side, go the opposite way, the same distance away. Questions about parabolas?
If you're given the directrix and the vertex, how would you know if it's horizontal or vertical?
By the direction of the directrix. So you'd have to plot it. X equals is a vertical line and it can't cross the directrix. Y equals would be a horizontal line and it can't cross that line. Alright, so moving on to an ellipse. For an ellipse, if we look at our standard forms, the only difference is where the letters A and B are, which are in the bottoms. So in general, we're going to have x minus something squared over something plus y minus something squared over something equals 1. And those are kind of our blanks to fill in. Again, it's not totally necessary to plot it, but for me, I think it's easiest to plot it. So we're going to go ahead and plot these out. So we have covertices at 0, -3. and -4, -3. We have vertices at -2, 0, and at -2, 6. So the first thing we need to find is where's the center of this thing, because that should be our h and k. That should be what's in those parentheses with the x and the y. Should be where the center of this thing is. And they didn't tell us where the center is. But the center should be, like the word center implies, right in the middle of this thing. So if we kind of line up those vertices and co-vertices, that center should be right in the middle of everything. So what would its coordinates have to be? -2, -3. Okay, so if we line up those vertices and co-vertices and find what's exactly in the middle of this picture, then we can find that center. So when we plug that in, again, we have to be careful because I'm going to plug in a -2 minus a -2 is going to change to plus. Plug in a -3 minus a -3 changes to a plus. For denominators, we want to look at how far we're going in the given directions. So for under x, we want to say how far is it from the center out to the side of this thing in the x direction. So how far is that? 2. But 2 is not going to go into our equation. What's going to go in our equation? 4. Because in the equation, everything needs to be squared. Same thing for under the y. In the y direction, we go from the center to the vertex. How far? 3. But we don't put 3 in, we put 9. We have another example of this, but are there questions on this example?
Just square those two top numbers.
You can't. It looks good in this problem that you could just take your h and k and square them. That only works in this problem because the vertices and co-vertices are still lying on an axis. If it was kind of totally floating out in the middle of something, it wouldn't work. But it looks good in this problem.
How can you know what the center is?
You want to line up your vertices and co-vertices and find what falls exactly in the middle of the picture. Alright, so again, for an ellipse, our equation is x minus something squared over something plus y minus something squared over something equals 1. When we plot this one, we have foci at 3, 5 and 3, -1. And we have vertices at 3, 6 and 3, -2. So we don't really know how wide this thing is, so it's just going to open around some width, we don't really know. Well, our center is supposed to be in line with our vertices and our co-vertices, but we don't know where our co-vertices are. So what we know then is it's just going to have to happen exactly in the middle of those vertices. Or in our very first section, we defined what that is. What is that point that's exactly in the middle called? The midpoint. So we want to find the midpoint of the vertices. So when we learned about a midpoint, how did we learn to do that?
X plus x over 2.
We added together our values and then divided by 2, which mathematically is also called the average. So we're taking the average of the 2 points. Just like if I wanted to know kind of what's my middle test score for students, I would find the average score. Here we're looking for the average of the 2 points to find the middle of the 2 points. So for the x's, I would do 3 plus 3 over 2. For the y's, I would do 6 plus negative 2 over 2. Which then turns out to be 3, 2. So that plugs in for our h and k. Then, in my picture, I can measure from the center to the vertex. And if this is at 3, 2, and the vertex is at 3, 6, how far is it from the center to the vertex?
4.
4. If it's going from 2 to 6, there's a distance of 4 there. I'm going to square that, 16, and where do I put that in the equation? Underneath the y, because that was an up and down measurement. I don't have any sideways measurements in this picture. So from the picture, I can't tell what to put underneath x, because I wasn't given any information about sideways measurements. But I was given information about the focus, and we haven't used that yet. C is the distance from the center to the focus. So how far would that be? This was at 3, 2, and this was at 3, 5. So the distance there is 3. And in your chart, you are given an equation about the focus. For an ellipse, c squared is equal to a squared minus b squared. So c is 3. A squared is the vertex number in the equation. So a squared is going to be that 16. A squared is the vertex number in the equation. So a squared is going to be 16. And what we need to find then is what is b squared. So we get 9 is equal to 16 minus b squared. Negative 7 is negative b squared. So 7 is b squared. And that's what goes in the equation. We don't want to take a square root because we want everything squared in the equation anyway. We squared the 4 before we put it into the equation. So we want b to be squared in the equation as well. So if you're given your vertex and your co-vertex, it's a little bit easier because everything just kind of lines up and you know about sideways motion and up and down motion. If you're given your foci, you only know about one direction of motion. So then you have to use that second equation of the kind of Pythagorean theorem type format, c squared equals a squared minus b squared, to find the other denominator. Questions?
Where did you get your midpoint information?
Midpoint we learned about in section 10.1, and that is the average of the 2 points. So I'm taking the average of the 2 vertices to find the midpoint. So our vertices at 3, 6 and 3, negative 2, I want to take the average of those. So add them together and divide by 2.
Where'd you get the 16?
The 16 came from the distance from the center to the vertex was 4, and then I square that when it goes into the equation. We have one more to talk about, which is a hyperbola, and hyperbolas are a lot like ellipses. So practicing the hyperbola will be kind of more practice of the same thing. So for a hyperbola, the equation is actually different depending on whether it's horizontal or vertical, because the letter that comes first in a hyperbola matters, and it tells us about direction. So for this, again, you don't have to plot them, but I find it easiest to plot our points to find direction. So I have vertices at 5, negative 4, and 5, positive 4, and foci in line with those at 6 and negative 6. So it should go through the vertices and open up around the foci. So now by plotting, I can see that this is a vertical facing. So in the table, when I look for vertical facing, that means y comes first. The center is going to be, again, the middle of the vertices, or the average of the vertices. So our vertices at 5 and 5 negative 4 and 5 positive 4, what happens exactly halfway between those? 5, 0. Right? 0 is halfway between 4 and negative 4. So when that goes into our equation, the 0 goes with the y, the 5 goes with the x. From the center to the vertex is going to be an important value for us. That'll go into our equation. How far is that? 4. Before we put it in the equation, we need to square it. So 16 is going to go into the equation where? Under the y, because that was an up and down measurement. The only other thing we can measure in our picture is the distance from the center to the focus. From the center to the focus is our C value, and that is 6. The focus doesn't go directly into the equation though. C squared equals A squared plus B squared is the second equation that we need for our hyperbola. So C is 6, so that gives 36. A squared is the number we already know, and B squared is the number we're looking for. So B squared is 20, and that's what goes in the equation. We don't need to take a square root because in the equation we want everything to be squared. Questions?
Where'd you get the 30 or the C equals 6 from?
C is the distance from the center to the focus. So if the center was at 5, 0 and the focus is at 5, 6, they're 6 units away from each other. That's a very like alliterative or assonant phrase when we think about like C, distance, center, focus. There's like a whole lot of the same sound happening in that sentence. So I can kind of help you put it together. Remember, C is the distance from the center to the focus. A little bit of a tongue twister. Right, your homework again is from 10.6, but it's 14 to 20 tonight.